So go ahead and enter your questions into the Q&A chat tab that you should see on the bottom of your screen. Or if you want to ask the question directly, you can just raise your hand and I can enable your audio. The first question, and Rose, you alluded to this or talked about this briefly. Can either of you, I guess, talk about what does it mean flooding the grid, and why is that an issue or challenge, and how is that being addressed, and what kind of careers does that relate to?
Okay, go ahead.
Sure.
Go ahead, Rose.
Oh, I'm sorry. Yeah, when we call flooding the grid, there's too much power going onto the grid and the grid can't handle it. So it's just an overwhelming amount of electricity or current going to the grid. And our grid is, well, it's kind of archaic, you know, so a little bit slow to make it bigger, to build out that infrastructure that is needed. And that's the problems that are being addressed right now. And that's why we have that CapEx 2050 with a huge expansion, but I believe it's already fully subscribed to. In other words, we're going to be building right after that 2050 goal is finished. They'll be building out more infrastructure. And that's where the battery storage comes into play. We're not, NextEra or Florida Light and Power is our biggest battery storage developer in the country right now. And they have offices in Minnesota as well, but they're our real hope for getting those larger batteries that can hold and store that extra electricity before it gets pushed, before the grid can handle it and push it out to your homes.
Yeah. So just to add that Florida Power and Light, that biggest battery, we are the one that are providing the intelligent software that will decide when the battery will charge, what's the best time to charge, when it will discharge, how much it will discharge, and all that. So you can see the engineering in action there also.
Thank you. Yes. Did that answer the question, Melissa?
I think so. And just a follow-up question, because I know, at least I hear a lot of buzz about renewable energy, but there's issues sometimes around the batteries and whether that's a renewable resource. Can either of you talk to that about the use of batteries and renewable energy?
Yeah, I'll talk about the storage in general, then I'll talk about the batteries. So the storage is not just a battery. There are different types of storage that are available. One of the storage that have never been in this country, that was built but never used, is the pumped storage hydro. So when the electricity is cheaper, we can pump the water to the top of the reservoir, and then we can use it. And it is completely green because it doesn't have any, anything that is need to be disposed or anything like that. It's completely green. We also have storage of a large mechanical object, a flywheel, that is kind of rotating, that's called as a flywheel. And there are few built into this in our country also. Gas, compressed gas, that's also another storage. When the electricity is cheaper, a lot of wind happening, we can store them and all that. The batteries are a little bit different in terms of that, is that the batteries give some certain controllability and the quick. So when we need it, the battery is the quickest that can give us that power. That's the reason there is a whole set of problem that we are working on, is that how much do we need all the batteries, or do we need how much batteries in what location and all that. And the other part is that the batteries will age and then we have to recycle. And now there is a whole set of researches going on, is that currently it's not fully developed, but in the next 5 to 10 years, I think there will be that they can be recyclable and all that. So research is also going on how to do that. So many ways storage can be exploited or used, as well as make them green as well. Thank you. I hope I answered.
Yeah, it looks like there's a follow-up question along the same line of, then what is the most efficient means of storing that energy, electricity, and is it the most efficient?
Okay, so I will first I can answer that, and I have to go a little bit more technical, but let me give it a try. So when we say storage, we always say I can store and I can get it back, right? Imagine money in the savings account, and whenever you want, you can get it. And money is in some stock, you sell it, takes a few days to get the money. This whole electricity storage is also like that, you know. So it is not just energy that we use, you know. There is things we use the energy that we use, but there are things like reserves. That suppose we have generators and generators are running, and one of the generator all on a sudden malfunctions, it doesn't work. Then what will happen? The grid is not going to go black because we don't have the power. We always keep reserve. And that reserve is a time domain reserve. That means I can get like 100 megawatt in 5 minutes, 500 megawatt in 10 minutes, 1000 megawatt in half an hour. So that these batteries and these storage resources cater to that. So battery quick, within few seconds I can get the power that I need. But after that, what I do? That's when the compressed gas kicks in. That's when the pump storage kicks in. So in a space of time, we have different storage that kick in. And then the replenishment, battery can quickly charge. Compressed air maybe comes next. And the pump storage will take the most time because it need to pump all the water from the tail race into the head of the reservoir. So this is called as integrated resource planning. We work on that to build the different storage for the system. Hope I answered the question, but please ask.
Yes, I think so. So then the next question we have here is, what are some simple things we don't really realize we can do to help save energy?
Use what you need to. That I always say that if you don't need to turn on the light, don't. If you don't need a 100-watt bulb everywhere, think about what you need and use accordingly. And that is probably the best thing that we can do to save energy.
And if I can just jump in the very near future, we'll have some badges available off of our website. Digital badging, one is energy conservation and one of them is energy efficiency. So it'll be geared towards the middle school students, but that would help identify what is actually consuming energy. And we don't realize it, but our televisions, if you're going on vacation, unplug them. They're still drawing some current, fans, everything like that. And I don't know if you, the students out there remember or had this kind of concept going on, but growing up, my dad would always say, turn off the lights. And that is such an important thing. You know, we don't need the television on in the background if you're working or excess of appliances plugged in. You can unplug them. It's that simple.
And Rolla, so just a quick follow-up question to that. So you talked about digital badges. So is this a educational program, or what is this, the badge system?
We'll be launching them hopefully soon. I don't have a launch date, but it'll be through our Minnesota Energy Center website, and they'll be free to and accessible to the students. And how we're going to launch them, I'm not sure. We may launch them to teachers and then they can monitor their students' progress. And it'll be like 8 to 10 hours for each of the digital badges. And they're going to build off each other. And eventually we hope to build a whole portfolio where you'll receive a kilowatt meter at home. So you can actually read and what a meter that shows how much draw appliances are taking on your house. And you yourself will be able to identify ways to cut down and conserve energy in your home. And even looking at energy bills, you know, very simple things that a lot of us take for granted because all we do is switch on the light, right? Turn on a light switch. So it'll be a learning process and a pathway moving forward. But we'll see how well the first launch goes, because right now we're going to be having our industry experts review the badges before we get them live.
All right. Our next question shifts gears a little bit. Can you both speak to your accomplishment that you're most proud of related to your work with energy?
Okay, Rose, you want to go ahead or you want me
Yeah,
to?
actually, I don't know if you guys are even born in 2005, but back in 2005, we got legislation for biodiesel going through the state, and I just helped with the lobbyist and testified up at the state. But in that first winter, there was a whole bunch of filter plugging going on in semi trucks. I mean, it was just total chaos and just disruption. But I was able to do the research to figure out what was going on with those filters and why are they plugging, because they shouldn't have. We've had too much testing in winter temperatures. And it came down to tank maintenance, and to figure that out was such a great journey. I mean, hit the wall running 10 times before you finally get it right. But that was a big thing. And then I also was able, as an undergraduate student, a student with just a 4-year, I was able to present that work at the AOCS meeting, the American Oil Chemist Society, and received an award for that research. So it was really very great thing for me.
Okay. And for me, I am an algorithmic person, so I create algorithms. So I created an algorithm that is, what does it do is that it looks into thousands and thousands of generator and transmission lines, and it produces electricity from the generator that is the most cost-effective generator. So it's a huge mathematical model it solves, and it produces, it reduces the cost of power. And this algorithm is used by many of the large electric operators and the transmission operators around the globe to reduce the power and to increase the reliability of the power supply. This is called as security constraint unit commitment for the technical name, but this is the algorithm. And of my all the things, this is what I'm really proud of.
Thank you. All right, so our next question says that there are many advances in energy producing technologies. Which is making the most advances and is the most promising? Solar, wind, hydro, nuclear?
Okay, I will I'll talk about my perspective about them, and I will start from nuclear. I myself is not a fan of nuclear energy, just because you know if something goes wrong, it's not good for the society, and there is always other ways to do that, and it's very expensive to build, to maintain, and there is always the fear in people's mind about the nuclear. Hydros are expensive to build, have a lot of environmental impact. So if you look into around the globe, nobody is building new huge hydroelectric plants anymore. But whatever is there, they're trying to make it better, make it efficient. But nobody is building huge ones. Small ones here and there, that's fine, but not the big ones, because it has a lot of environmental impact on that. Next comes the wind. Wind is evolving. I will say why it is evolving. It is not just the blade, but the efficiency of the blade. The efficiency of the blade to withstand different weather conditions. The maintenance of the blade, the longevity of the blade. So it is still evolving. And so it will probably take a few years, another 10, 15 years for it to kind of get refined and better. But again, the wind is, it's difficult to build, takes a lot of manpower also to manufacture them, install them, and to maintain them. Solar is easier because the installation is not that hard, but it has life cycle, and after life cycle you have to recycle and there is always that recycle issue is there, but they're easier to produce and install, and easier to control also. They can face the sun. There is different types of mirror, and you can use it to control. You don't have to worry that much about the other than like bad weather like wind and others. Pretty much they withstand. And so none is really the best. They're all trying to become the best, and trying to be and depending on where. For example, in North Sea, that is the north of Germany, it's extremely covered with always cloudy. So you can't imagine putting solar there. So it is full of wind turbines. And then if you go to Arizona, we can cover the whole state by putting solar panels. So, Rose, please.
I actually have to agree with you completely, and realize, everybody, that we're not building new nuclear plants in Minnesota. The ones we have have hardly changed inside their plants because they can't bring in a new computerized or digitized software system to what the original plant was run on. And it's almost like you're walking into the Twilight Zone when you go into those operations rooms. Very neat, very cool. And wind, and realize too that advances in wind as the vertical axis wind turbines, and my finger isn't showing very well. But a lot of research, especially right there at Mankato State, has been going on with the vertical axis wind turbines in the last couple of years. You'll see those as smaller ones and really good for like parking lot lights. As almost all the new Hy-Vees have the vertical axis turbines, and they're just, all of a sudden you look at it, it's like, oh, that's one of those, So that's a really neat advancement in technology, I think. And the turbines themselves, they take up such a small footprint compared to a solar array to get the same or equivalent amount of power. So that's a payoff too that Ashman didn't address, but that is a big one. And the entire Buffalo Ridge, which is in the southwest Minnesota here, has gone through a recommissioning of the solar farms on the Buffalo Ridge. And these are bigger and better, and there's fewer of them out on the fields now, which is really a neat thing. So it's sort of recycling in itself.
All right. Rose, the next question is probably a little more directed towards you, but Ashman, if you have any thoughts on this.
Yes, sure, definitely.
As well. But Rose, you had mentioned that we're going to see a large growth in solar careers in the next 30 years.
Right.
Are there any other career fields within energy that we see as a kind of a promising field to enter? And then also, what is education requirements related to those?
Sure. The Aegis technologies, which is your smart technologies, that would be where you will see some growth in the state system, I believe. And so that students learn how to operate the SCADA systems that operate the wind farms or the solar fields. So that's a promising field. We don't have that program in place yet, but there might be tidbits of it in the engineering education programs, or in some of the electrical programs as well, and in our wind and our solar programs. So you have pieces of that. But the one thing to realize is weeding out process for wind students is that if you're afraid of heights, that's the wrong career for you. And a lot of students don't realize they are that concerned about height until they actually do a tower certification climbing up at the Morris U of M campus. And they're 250 feet in the air, so it's really an interesting perspective for students. And but most of our energy related programs can be completed in 1 year, and some of them are 2-year AASs. And then I know that the engineering programs have different certificates as well that they add on to theirs when their students are doing some of the research in, for instance, solar, when I was working with Mankato over the last couple of years. So there's opportunities, but here's the other thing. If you're a mechanically inclined person, there's a lot of companies right now, because there is such a workforce shortage in the energy fields. They'll take you on right off the street, and you'll start working on as an apprentice for a couple of years. So you get your hands-on education while you're learning and working.
So from my perspective, I will say that there are many different areas that you can work. If you get into bachelor's of engineering or you want to pursue. So you can work on the devices, which is, for example, how to make the motor, electric motor, more efficient using superconducting material. How to create an intelligent system that is self-managed. You don't have to it is depending on the condition, it is managing. If you become an electrical engineer, you can think about, for example, if the hurricane comes or if the tornado comes, how can our grid stay safe together? And so all these are, each is a field of study on its own. You can, start taking interest into that and go to college and can do some research in this area. So really, I will say infinite possibilities out there for the young people to really pursue those careers.
Thank you. All right, so I have one more question, and then we will wrap up with both of you sharing just any final thoughts that you might have. So the last question is, thinking through the viewpoint of a middle schooler or high schooler, what advice would you give them as they start looking into or becoming curious about careers or career pathways?
Just do it.
Go ahead.
I just said just do it. These are one of the fastest growing industries in our working world. That it's engineering, it's energy, and health force. Those are in IT. Those are your big ones. But it's amazing how much we don't necessarily work so much with health force, but we certainly overlap in engineering. We overlap in manufacturing. We overlap in agriculture. So there, one direction can take you many, and you'll be able to find your pursuit once you start diving in.
Yes.
All right, so then I want to thank everybody for joining us today, and I'll give Rose and Ashman just a couple seconds here to collect some final thoughts. We appreciate everybody joining us, and we do have one more session left in our series, which will be in 2 weeks on the 23rd. Where we will have 2 more professionals joining us and sharing some of their insights. And so we hope you guys can join us then as well. So I will go ahead and turn it back over to Rose and Ashman to share final thoughts. Who wants to go first?
Ashman.
Sure. I'm no problem. Yes, I will say that, I passionately believe that we can, work, all of us work together and to produce a zero carbon grid, and we can reduce the environmental effect. And so it's just like, starting something, we started it, and you all can take it forward. So my best of luck to you. Be the best engineer in the whole world, and be the pioneers that we all Americans always are, and be the best in the world. That's what I will say.
Yes, and I'm sorry I have my Christmas clock is going on in the background. We had snow, so I could turn on the Christmas music. Sorry, everybody. But the future's in your hands, and make it the best it can be. Work with your hands, work with your minds, work with your cognitive abilities, and jump into one of these industries. I think you'll find it to be really fascinating all along the path. And remember, like I said, you can go to school for one thing, but your direction can change, certainly, in your future careers as well.
All right, well, thank you, Rose and Ashman. We really appreciated all the insight and information that you shared. And I hope everybody has a great rest of your week and stay warm. Enjoy this last bit of little bit of warm weather that we have. All right.
Thank you. Thank
Bye.
you,
Thank you.
Melissa. Thank you, everybody.